So another talk about blockchains, but just to make things like maybe take a little break from all of this technological stuff, let's take a look at this beautiful world map that just colors our beautiful world into two halves, the orange side and the gray side. So maybe you know that the talk is about blockchains, and within this context, would any one of you guess what the two types of countries we do have now in our world? Okay, I'll just be nice enough to give you the answer right quickly. It's just the ones that do consume much more electricity or energy than the Bitcoin network burns, and the ones that do consume less than the Bitcoin network burns. And now maybe the next question that will come to everyone's mind is why or where is all that energy being gone? It's in feeding those huge beasts. It's just sets of chips and super powerful CPUs that are kind of concatenated in huge data centers, maybe I don't know how many times the size of this room in which we are packed here. And then maybe the next question that will come is, why do we ever need that? So Babak also talked a bit about this. He talked about all of these nice things about blockchains, and they represent this kind of single version of the truth whatsoever, how this thing is operating, what is the energy feeding it. So it's basically this. And when it comes to Bitcoin, people say, okay, we do burn energy to create and find new coins. It makes too much sense, right? I mean, if anyone can find it at no cost, then it will not be a coin that has any value. So we need to spend some effort into finding it, and the effort now is not physical, it's just electrical. I will make my chip overwork. Well, that being true, I do admit, I'm afraid that this is just the visible tip of the iceberg. So there is much more to that when it comes to Bitcoin and blockchains. This proof of work and this mining that we all know as being just about finding new coins and becoming super rich is actually to reach consensus about this single version of the truth that Babak has just talked to us about. And so all of this, spending all those amounts of energy and all of this mining and burning is actually for the mere cause of reaching consensus on this version of the blockchain. Let me just explain this a bit more. So in a normal easy centralized setting, we do have one clearing agency or one centralized entity that we all trust, like let's say a bank or a government that contains all our transactions in a ledger. Now, to simplify things, I mean a blockchain is nothing, it's just a chain of blocks. And what is a block? It's just a set of transactions that has been kind of made into the system at a certain time t, and they are then ordered by time. So it grows in this direction. So a blockchain can also be centralized somehow, theoretically, and if we just give it to this clearing house, then we don't have any problem. We trust the house, it's the one that represents to us the single version of the truth. Now the problem comes, like in all peer-to-peer computing, is when we want to decentralize this, because for a reason or another we don't want to trust that central entity. I think in the previous talk we also heard about that. Then, like in all peer-to-peer systems, the problem comes into that version here of this chain that was only one into the central clearing house will now be recopied. So there will be different copies at the level of every and single peer, and the problem will be how to make sure that it's the same version that exists at the level of every single peer. And it's just like agreeing on the state of the system, or the transactions, or whatever things, events or truths that happen in the system. Of course, things get even more complicated when it is now time to add new things into the chain, to add new things into the ledger. There are new events that are happening all the time. So, in the previous case, it was only the central thing that says, okay, now this happened, we will append this. Now, in the decentralized scenario, everyone will be having the right to say, okay, I have some new information that I heard of, and this is the truth. This is my version of the truth. So now which one will be given the right at any single time t that is now to say that this is the only truth that you all need to accept, and then all the others need to say, okay, we accept and we do the review. And for all the ones that are from the field here, this is the classical kind of Byzantine agreement problem, or Byzantine leader election problem, that becomes even more complicated when we do have a public network in which new nodes can join at any time. So maybe at that time it's the time for this one to say that's the new truth to be added to the system, At exactly the same time, another entity and peers say, no, I do have another version, and this is now the truth that you do have to believe in. Of course, there are many easy solutions. We can say, okay, let's just agree around us that we will make it a round robin or a majority voting, and that will be kind of the truth that everyone will accept. But since, again, it is an open and a controlled network, some people that are good might leave. Some malicious entities might just duplicate, forge identities, and so this will just make any voting or round robin that will perform just useless. So this problem has been known and very well formalized in the domain of distributed and peer-to-peer computing, and it has been known to be solvable as long as you have maximum a third of the population being malicious, I mean doing all these bad things to represent different versions of the truth. Now what blockchain and Bitcoin come up with is this nice idea of saying, okay, let's play a game in which we do solve some hard, difficult mathematical problem that can only be solved by brute forcing, which is this proof of work or this Bitcoin mining, and whoever comes up with a solution will be the leader now from whom will accept the single version of the truth. So the process goes as easy as every single node collects all the transactions or all the events that they heard of. They race to solve a cryptographic puzzle that can only be brute forced, and then they prove, the first one finding it, they say, okay, I found it, and then they add the collected things to the chain and everyone agrees. So it gives these nice advantages. One CPU, one vote. It's so stupid from my side to forge new identities. It means that I need to acquire new CPUs. So it results in security and in simple and easy verification. It's very hard to find this solution, but it's very easy and cheap to verify. The disadvantage now is that it burns too much energy. We've seen it in that map on the first slide. So then the question is, can we reduce the carbon footprint of this proof of work, this consensus mechanism that yes creates for us Bitcoin, but also allows us to reach this consensus mechanism? There have been some trials already and some suggestions, the most prominent of which is this hybrid proof of work based on waiving it by stake. So basically in a system, the more money you have, the easier problem we will give you to solve. And if you don't have any money, you are just a beginner, we'll just give you a big problem to solve. So basically it's installing a mindset of, if you are rich, the richer you are, the more trusted you are. Do we really want that? This is what I question here. Does it make sense that the richer or the richest is always the best? And also the second thing, there are many application scenarios to which we want to apply blockchains that are not necessarily having this monetary kind of format in which we can value people based on how much they earn in the system. So from here we asked, instead of waiving it by stake or anything that is financial, why not to go back just to natural trust that just comes naturally in whatever large-scale collaboration we humans have among us. So if we operate, even if I don't know you, I don't trust you, it takes me some time to deal with you, and then I can start having an idea about what type of people you are. So then, if we agree that trust is very inherent in many use case scenarios, let's say universities that want to manage this blockchain distributed thing for some events that they happen, like, I don't know, sports clubs, etc., then peers can develop trust among each other. Each peer will gain a trust value based on how much he or she is trusted by the other peers in the network. And then we can simply say, as we said before, the more money you have, the more trusted you are. Now, the more trust you gain by your behavior in the system, your good behavior in the system, the more privilege you get at mining or at solving these easier problems. Okay. So that doesn't come free of challenges because we are still in a decentralized system. And so we don't want to rely on any central entity, and we want all these trust relationships to be managed in this pure peer-to-peer system. And one of the solutions is just to let these things happen freely among individuals, to allow them to trust whoever they want, to revoke the trust at any time they want, to assign to it weights, probably. Now the problem is, once we do have that, how do we agree on this truth, the single version of the graph? Because everyone can assume that that's my view, I'm more trusted, and the other one will say, no, you are not the one who's more trusted, I am the one more trusted. Luckily enough, we do have the blockchain itself that gives to us this footprinting of the truth. So we can make use of it to just store one single digest of this trust graph at any time. And it's quite light, it's just like a hash of Merkle tree here that is stored in every block at every single time whenever this graph is changed. Now, based on that graph, we just compute a trust metric for every single node. So these names are just saying that A is trust in Q, for example. Based on that, we are making a computation of trust metric for every single node. That should be deterministic and verifiable. Deterministic means that anyone who computes it, who runs the algorithm, need to find the same numbers. Verifiable, independently, we can compute it without the need for any other peer, so that we save this decentralized thing. And then based on that, now once we have these numbers, it's just having like the stake, we run the game of people are, for example, this one is privileged to mine at a lower difficulty, which means that less energy is being spent by that specific individual. Sorry. So I think they are waving that I don't have more time. So the idea is just like, again, as simple as that. We have a trust graph. Some people are more trusted than the others. At every single time when we are about to add a new block, a new set of transactions to the chain, we get the ones that are at that time, the ones that are highly trusted, and we give them the privilege to solve this proof of work or to mine at a much lower difficulty. Of course, this isn't as easy as that. These are just some kind of questions that maybe I will leave you with. And if you are interested, then you can come in the afternoon. We can have a discussion over the poster. So if we have a few highly trusted peers, then we can end with the monopolizing the network. That can happen exactly as we have a few percentage, like a small percentage of the population monopolizing most of the wealth in the world. That goes also with trust. That's quite natural. We don't want that to happen because we want still a world of fair chances. If identities are not managed, then people can still use this forging identities to increase their trusts. And so we don't need a smart trust metric or strategy that just normalize the chances for all people for an equal world with equal opportunities. Okay, thanks. On that, I will